Hello everyone, it's actually the 11th of October, but apparently somewhere in the States it's the 10th of October, so we can still get to work on the 10th October Leetcode challenge. Let's check it out. Minimum number of arrows to burst balloons. Damn. Okay, so there are some spherical balloons spread in two-dimensional space. So we have balloons in a 2D room, like on a screen. Okay. For each balloon, provided input is the start and end coordinates of the horizontal diameter. So it's just the x-axis across the screen. Okay. Since it's horizontal, y coordinate doesn't matter. What do you mean it doesn't matter? But didn't you just say it's a 2D room? Hence the x coordinates of start and end diameter suffice. Okay, so we just have the x coordinates, but why doesn't it matter? For what doesn't it matter? What do you mean it doesn't matter? The start is always smaller than the end. Okay, that makes sense. So we don't have negative balloons. They exist. This is nice. An arrow can be shot up exactly vertically from different positions along the x-axis. So it's like an arrow that shoots up. Okay. A balloon with x start and x end bursts by an arrow shot at x if x start is more than or equal to x, smaller than or equal to x end. Why do they use x here? I would not phrase this question like this. I'm already getting a bit confused. I think x is the x of the arrow and x start is the x of the balloon. Why don't you say x of the balloon start and x of the balloon end and then x of the arrow? Okay, so yeah, an arrow pops it if it's within the balloon. There is no limit to number of arrows that can be shot. An arrow, one shot, keeps traveling up indefinitely. So it travels through the entire screen. So that's why they probably mean it doesn't matter the y coordinate, right? Because it basically means that, let's just read this and now draw something to visualize it for myself. But yeah, given an array points where points I is x start, x end, return the minimum number of arrows that must be shot to burst all balloons. So the way I imagine it, so we have the room, something like this. So this is the x, this is the x, this is the y. Why did you crash? Come on. And I just figured I have something nicer to use than paint. I have my room. This is my x. This is my y. So let's say this is 0, 0. So 1, 2, 3, 4, 5. Okay, let's just keep it at that. So 1, 2, 3, 4, 5. So let's say we have a balloon here, a very weird balloon here, another very weird balloon here, maybe a balloon here, and we're basically asking what's the minimum number of arrows we need to use to shoot up these balloons. And since the arrows can travel across the y coordinate, but they travel from the bottom here, and they can pop as many balloons as they have access to. So let's say that this starts on the 1, this starts on the 0, this starts on the 0 as well, and then on the 1. I'll write it inclusively. This is 4, this is 4, this is 5. So these are my balloons. I'm sorry that they're awful, but I guess they at least represent some spherical shape. So if I shot an arrow at the 1 coordinate, then this will pop this balloon, this balloon, this balloon. And then I need one more to pop the last balloon. So this is gonna be my solution. My solution is gonna be 2 arrows. How do we solve that though? This question sounds very similar to the one we had before. Where is my code from before? This sounds extremely similar to remove covered intervals, right? Because basically we want to remove the balloons that are covering each other. And for this task, I remember that we solved it. I did not solve it optimally. I solved it by comparing everything. But basically, this comparison, I could have sorted the array first. So what does this mean? I mean, I can sort the balloons by what? By their end coordinate, right? Because if I have the balloon that ends first, I have a bunch of balloons. I start from the 0th one. I take it as a baseline, and as long as my balloons are sorted, I can have the balloon that ends first. So I have this balloon, because this one ends on the 2, let's say. This ends on 4. This ends on 5. So this one ends on 1. So I'm sorting the balloons. I know that this is the first one I have, and I'm saying it ends on 1, and then I'm comparing it to the next balloon. If this one is within range of start end of the next balloon, then this basically means my first arrow already covered it, so I don't need to do anything else. Then I compare it with the next balloon start end, and the next balloon start end, I again compare it. If it's within bound, I compare it with the next one. If the next one is not within bound, then I count that I need to use one arrow to shoot them up, and then the next one becomes my baseline, and I start comparing it with the rest. And I guess I need to make sure I don't have an off by 1 error. I mean, it's very likely that I'll do some off by 1 error, but I guess we'll fix it. But this basically is the same task. I think we just solved it with the remove covered intervals, so the 4th task. Okay, well, let's see if we can do that. I'll get the examples. I guess I'll use some of the examples for testing. How do you use those custom test cases though? So weird. Kind of dislike their interface. Why cannot I see this? What's wrong with it? Why is it outside of my window? Come on. What does 1, no, 2, 3 mean in binary tree representation? What the... Okay, whatever. I'm not even gonna bother. I'm just gonna keep using IntelliJ for now. So let's just take their function name and call it... Okay. So I have some points. So obviously the first thing I'm gonna do is array sort. So sort the points, but I want to pass a function, so I'm basically passing a comparator, and the comparator is something that takes an int array, so it's balloon 1, balloon 2, and I'm gonna say return balloon 1 1 minus balloon 2 1. I guess don't need the return. This looks like something that might be even nicer on one row. Okay, so is this what I want? I want to sort them in so that the smallest balloon is first, the smallest, the one that ends first is first. So how comparison works is if this is negative, then it will be sorted before. If it is equal, then, well, it's equal. Do I need second? No, if it's equal, it doesn't matter at all, because if it's equal, then I'm popping both anyway with the arrow, so it's irrelevant. And if it's bigger, then it should go after. So if balloon 1 has the end point, here the ending x of 5, and balloon 2 has 6, then 5 minus 6 is gonna be minus 1. So 5 will be first. So I think this is correct. Okay. And I really like how it looks in Kotlin. This is much nicer than the Java lambdas. So I'm sorting the array. Now I have the sorted array. So let's like go through. So I guess I need the first one. And I guess I didn't see any constraints. Can they be 0 balloons? Points.length? Yeah, it can be 0. So this means I need to do if points size is 0, return 0, I guess. Is empty. Okay. If points is empty, return 0. And then the length of every balloon is 2, so I don't need to care. Like, this is always true. Like, I always have a end coordinate. And there are some constraints. Oh, wait, they're within min and max integer. Can something go wrong if I have like a... Oh, every balloon has at least one size, so this is nice. But I think it doesn't really matter. Can I have some problem if I'm extracting like min integer minus min integer? Like some overflow stuff? Like, what's gonna happen if I have min integer in the for the first balloon? So like, yeah, this here, very short example. This is my x, and this is like min int, and this is my min int plus 1. So let's say I have a balloon here, and I have a balloon here. I guess I can write them just flat 2D. It's gonna be easier to spot. And I'm asking if this is first or this. So what I'm saying is min int plus 1 minus min int plus 2 for my function. Let's just check this out really quickly. Return something and say print integer int.min value plus 1. So this entire thing I want to deduct int.min value plus 2 and see what happens. This should be a positive number, right? Because it's gonna overflow. IntelliJ, why are you taking so long? That's minus 1, so that's good. If this was like some bigger number though. Oh, I guess it overflows properly. And if it's this should be 1. This is correct because this is like to the right. This is min int plus 1 minus min int. So if this is the first balloon I'm comparing and the second, this is as if I'm saying is a balloon that's like this big, although I think it doesn't even exist, bigger than this one. Well, answer is no. Like this one ends one to the right. So it's still correct. Like this is the one to the right. This is the one that's almost a single point. So I guess it works even for these negative integers. Okay, this was concerning a bit, but it's not concerning anymore. So now I take the 0 point. I have at least one, I'm sure, because I did the check. So var like I guess I'll call it end is points 1 points 0 1, right? It's an array of arrays. So yeah, the 0 of array, so the 0 of balloon, it's end coordinate. And now I want to do for for I indexing 1 to points last index I think this is pretty sure this is inclusive. I need to learn how to use Kotlin better. I keep forgetting like whether the points were inclusive and until was exclusive. I think this is until is exclusive. So yeah, this is good. So for I in one points last index, I'm gonna say if so I'm gonna extract the balloon is points you know what? I'm gonna make this nicer for me. So this is not like an algorithmic thing. We don't need to do it. It's actually gonna make our algorithm worse. The runtime is gonna be the same. I'll go through the runtime. It's not gonna make the runtime worse, but it will make it much nicer for me to work with this crap. So I'm gonna make a class, like a data class, balloon, and balloon is gonna have val start and val end, which are ints, and it's gonna have I'm gonna have a I'm basically gonna map this array to that. So I'm just gonna say val balloons is points.map the point to a new balloon. How do you spell balloon? Balloon with double L. Okay, balloon. So create map to a balloon with it 0, it 1. So now I can just say the end is balloons 0 dot end. This actually, if I was using a lower level language, so let's say I was using C or C++, I could create a structure that's basically free. Because here in Kotlin and Java, I'm allocating extra space, which I do not need to do. But I mean, yeah, this is something, as you probably noticed, we don't need to do this. We can just keep using the array. So I'm adding an O of n space extra needed to solve this question, but it's just making it nicer for me to work. And if I'm working with any sort of real system, I'd much prefer to make the code have better readability rather than make it more optimal. And then once I have solved the problem and I can benchmark whether the solution is good enough for me, whether it's space or time, then I can optimize for like these fine tunings. Like let's say I have so many balloons that is becoming troublesome for my system, then I can actually like remove this and optimize algorithm, especially if I have written test cases to cover it. But yeah, let's just keep it at that. So my balloon is balloons 1, balloons I, since I'm starting from the 0th one, and here it's the first one, and I'm comparing the ends. So if end is within the start and end of the balloon, so end, I can actually add a method now since I have a class. I can just say is within. So, or it can be even an extension function to the int. So if end is within balloon, and this would be an extension function to int. This is like a fun int is within balloon with a double L. And the answer to this is return, or it returns a boolean. This is a comparison, and return b is return this is bigger than or equal to b dot start, and this is smaller than or equal to b dot end. So this is like, I'm asking if the endpoint is within the balloon that I'm currently comparing. And I think this comparison looks nicer that way. So if it's within balloon, well, I mean, I do nothing, I just continue. So maybe I need, if it is not within. Well, I can just say this. I could write a second method, but or even I can do private fun int is not within the balloon boolean and return this is within B. I guess I don't need to do these things, but it kind of makes me feel nice when I have a solution that I enjoy how it's written. So yeah, I mean, obviously, the more function calls you add, the slower your code is, and the previous thing I said is still the same. I mean, obviously, deferring computation is more expensive, but in current computing, this would be like microseconds. Usually doesn't matter at all. So having as many functions as possible is actually beneficial, not to the runtime, but it's probably gonna give you the same runtime, and it's gonna make it nicer to reason about the code. And I mean, obviously, I mean, when I mean the same, I mean perceivably the same. It's gonna be some microseconds slower if you're having too many function calls. But yeah, if the balloon is not within, if the index is not within the balloon, then I need to count arrows. So I'm just gonna say arrows, which starts from 0. So arrows plus plus. And my new end is, well, this I need to add the second del here, balloon. These balloons end. So let's say I'm gonna check for the off by 1. Let's say my balloon has I'm checking the last one. So the semi last one is not covered by the last one, then I'm gonna add an arrow here for the last one. So this is good. And if the semi last one is within the last one, then I'm not adding an arrow at all. So I think I'm like, let's say I have the case where all balloons are covered. Can I just like get a new sketch? So let's have just X again. It's like 0, 1, 2, 3, 4. So let's just say I have something like this. I have this balloon and this balloon and this balloon. I mean, I have something that I can shoot with a single arrow. So I'm sorting them by end, so it doesn't matter how they're sorted. So I start with the first one. Let's say I start with this one. Is it within the next one? Yes. Is it within the next one? Yes. So they are all within each other. So I don't count a single arrow, because I only count arrows when something is not within. Does this mean that I need to say +1? Like, or just start from 1 arrow? Just assume that I need a single arrow at least. I think it's reasonable, because I'm always gonna need at least 1 arrow. And I'm always not counting the last iteration, like the last balloon itself. Because if I had like this, something like that, I'm counting this. So these two, I'm gonna start from the first one. Is second within? Yes. So I'm popping them both. Then is third within? No. So I'm counting arrow plus plus. And then this one, I don't have to compare it with anything, but I still need to pop it. So I need to return 2. So I think I just start arrows from 1, because I always need at least 1 arrow, because if the points array is empty, I'm just gonna return here. Why did I not spell balloons properly? So just return arrows. This should be solution. Not custom test case though. Yay, accepted. Amazing. So yeah, what is the complexity of the algorithm? Basically, here is my slowest runtime. So sorting, I'm not sure which algorithm is used here, but it's the Python implementation actually. I think it was called team sort, right? Implementation from Tim Peters. Team sort. Okay, cool. Anyway, so this is n log n. So n multiplied by logarithm of n. So this is the slowest runtime. And here it's O of n. Although I mentioned this, we can skip this. And this is also O of n. I'm going through all the balloons once, so I can just skip them because O of n is smaller. So the biggest worst time constraint is determined by multiplying the number of balloons by a logarithm of the 2 logarithm of the number of balloons. So this is my runtime, and my space complexity is actually O of n, and this, as I mentioned, I can drop it. I can solve the same question without using the extra like array of balloons at all. So if we assume that we don't count the points since they're coming from outside of our function, we can have O of 1 space, since we can basically solve it by keeping only 2 variables, number of arrows and number of like the index of the end. So just two variables. So we can have a constant space, but I mean, I might as well just use it to make my life easier and my code nicer. So I have O1 of space. Since for our system, if we abstract ourselves from the function and think about the system itself, we're somewhere allocating the points array. So yeah, we're just gonna do that twice. One for the points array and one for the balloon array. But obviously, as I mentioned, this is just for convenience to make my code more readable. It's definitely suboptimal in a language like Kotlin or Java, where you do not have a free struct, and in a lower level language where you have structures which don't really, like, they're just a way to name memory in space. They're just a way to name variables. Then it would be probably indistinguishable from the real deal. But here it's O of 1. It's not O of 1 because I'm creating this. But as I mentioned, yeah. Let's see how other people solve it. Oh, screw you. I don't care about the solutions then. Oh, there goes discussion. Is this where we were looking for the solutions? Thumb up for the last test case. What is the last test case? Golang clean solution. If len is 0, return 0. If len is 1, return 1. Oh. I mean, you can probably hard code a bunch of these solutions. Actually, I heard that competitive programmers, if they are not competing on time, like how fast they solve the algorithm, but they're competing on runtime, what they're gonna do is, besides using a low-level language like C++, they're going to first solve the problem and then cache a bunch of solutions and add them with like if statements at the beginning, so that so that their algorithm covers, like, cheats the test cases by already knowing the answer and not doing the n log n, but instead doing a O of 1 if check or switch check. So that's funny if you want to optimize solution, I guess. So he's doing a sort of a slice. I guess he's doing a much more complicated sort than ours for some reason. And then he takes the end and shots and end, one endpoints. Actually, I really dislike this syntax, by the way. It might be just me, but I think Python people do it a lot. I guess Go people do it as well, where you are assigning multiple variables that have nothing to do with each other on the same row. I mean, shots 1 and is this. They're two totally separate things. Like, you don't need to add them on a single row. It's much more confusing. it takes more mental energy to read it, even though it takes a single line instead of 2 lines. It takes longer to read this single line than it would take to read the other 2 lines. So now he's doing the same thing, but with a continue. Yeah, and returns the shot. So it's the same algorithm. But I don't know why he had more complicated sorting. Short and sweet. Sort, count, while something, do the check. So he's actually just, he has nested whiles, but I think his runtime is the same because he's still just gonna, internally he's gonna count through all of the covering balloons, but it doesn't matter. I mean, it's probably more confusing to have 2 whiles. I think I prefer a single while. It's the same runtime. JavaScript. Well, I guess everyone solves it this way. Like, it makes sense to use it with the sort, because if you don't sort, you're basically doing quadratic time like I did last time, n squared. But yeah, it's really funny how this is literally the same question as last time. I mean, we're just checking for the covering intervals, but before we had to have the intervals covered in their entirety, which I actually was really confused by the wording of the problem. And here we don't care about their entirety, we just need them to be touching each other, like to be within each other. So I was actually attempting to solve this task in the previous question, like here in the remove cover intervals. But yeah, that's a cool question. Let's just type it to GitHub really quickly. Add it commit. So this would be solution for day 10. Minimum number of arrows to burst balloons. Damn, this is a long name. I have a bunch of Git aliases. I'm sorry that I'm not explaining them, but if you want to, if you want me to explain more about Git, then you can just leave a comment below, and I'd be glad to do something, since I don't know which part of Git would be interesting to be explored. I actually, on my first year as a software developer at one of my previous companies, I was struggling a lot with Git, so I spent a lot of time to learn some of the internals and mostly break a lot of stuff so that I have to force myself to fix them. So I learned the hard way. Hopefully I can maybe help somebody to skip the hardest part of the hard way, because you cannot skip the hard way at all in its entirety. You need to like break your head against the wall a couple of times with Git to appreciate it. So yeah, it's uploaded, and yeah, that's it. I'm gonna post the link below, so you can always find the code below if you want to check it as a code instead of just like watching the video. And thanks everyone for watching. Hopefully this video was useful, and see you all tomorrow.